Welcome to the webinar Visualizing Wood Sustainability held at the Royal Danish Academy in Copenhagen. My name is Olga Popovic Larsen. I'm based in the Institute of Architecture and Technology, and this has been organized as part of a project that I'm doing together with my colleague Zan Brown, who later will be facilitating the question and answers. We have a list of speakers. We're really excited to have some very interesting talks today. And we have people who are from the school, we have Milan Jacevic. We also have Martin Tamke, but we also have people from around the Scandinavian countries like Pasi Aalto from Trondheim. We have Mark Hughes from Aalto University, and also we have Alison Martin from Italy. This is the plan for the day. After the fourth speaker, after Alison, there'll be a short break. If you wish to ask any questions, please write in the chat, and later these will be taken up in the discussion at the end of the session. Materials are really important in terms of sustainability. In this diagram that we see here, taken from the journal Nature, we can see how the carbon pool has been formed, but also later how by mineral-based construction materials we have depleted this pool. So now we have this great opportunity to turn the situation back if we work with bio-based materials as wood, for example. Wood is one of the few building materials that actually makes a negative impact. If we look at the diagram to the left, we can see if we compare it to concrete or steel, it's only wood that makes a negative impact. And I think this is really important. I also really like this quote that kind of suggests that wood is a really good material in terms of strength and low cost. In the building sector, we create a huge amount of waste, and a lot of that waste is also wood. But production of wood is also wasteful, and how we use wood today is very linear. For example, from a tree trunk, only about half of the wood comes into use in construction, and often then this ends up here. So I'm sure that Mark will talk about it, but another way of working with materials could be cascading of materials or cascading of wood, where there's a more circular approach used. If we look how structures behave, and if we wish to increase structural efficiency, these diagrams show that actually if we use arches, it's a lot better than using a truss, which is a lot better than using a beam. So an example of a very efficient structure is this little dome that we built, where we worked with minimal bending active structures, and we tried to optimize the material. In that, we use a structure that has got, it's only 12 millimeters of plywood that is really spanning 5 meters. It is a kit of parts, but beyond that, this structure is built not to end up in waste, but actually it's been planned already in the design that it could be used for another or several more lives. So it's designed for disassembly. And after the end of life, it was taken to another location and re-erected, and this was done several times. So the notion of what is waste could be thought in different ways. If we work, when we work, we're really inspired by nature, and we would like to look up to biological systems and how they use information. They're information heavy rather than energy heavy. Also, for the next project that I'll show, this paper by a young MIT researcher, follows availability, was also inspiration. Here he looks at steel members, and it's kind of a stock of elements that he has, and he works with a digital tool that then helps him define different geometries for the use of elements that he's working with. When we work with waste wood, the challenges are different. It's not only that we have different lengths, we need to make a structural composition, we need to think about the geometrical complexity, buildability, quality is really important, but most of all, I think it's also to come up with an aesthetic expression that doesn't give something as looking as secondhand or less of quality. So in our project where beside myself, Zan and Caio Castriotto, our visiting PhD candidate from Brazil, was involved, we worked with the aims of optimizing short elements and coming up with a good structural form, that we deal with the complexity in a good way, that we have a very easy to construct structure. We had to be sure that it performed well, but it was really important for us to work with proportions and tectonics so that we have a good aesthetic expression, so that it doesn't look like something less good. So in our waste wood canopy, we looked at the waste wood imperfections as a design agency. So a few days ago, literally, we finished our demonstrator where we built it on site in 1-to-1. And it's a structure that works again through arching. It is a two-way supporting, in a way, grid shell. It is composed of short elements, and this is the design team. And Caio and Zan built it on their own with no extra tools. It has optimized connections where all the connections are identical and only a single bolt holds the four beams together. It is designed for disassembly, and literally last week it was taken down to be re-erected to another site. When we think of wood, we have a whole taxonomy of defects, and this is of new wood. But what are these defects in old wood, in secondhand wood? So there's many more, and we would like to explore ways of how these imperfections can become a quality, how they become a design agency in the design. So to do that, we tried to remove some of the qualities so that we can see them. So for example, in these photographs, if you remove the color, then you just see the structure of the wood. And then it kind of, you think of it in a different way. Or we tried to use casts where, again, it's kind of, it takes away the notion that we're working with wood. Then we just concentrate on the marks on the wood and on the defects, but we see them in a completely different way. Also, a lot of work went into scanning pieces of wood. And this was done with the aim not only to understand the geometry, but also to look at a different way of representing wood and wood quality. Let's see if this is going to work now. Yeah. So basically, we wanted to create a tool that is interactive, where you could read, you could click on, and you can find out what this imperfection is about. And then this is amazing for me, this drawing, how when we draw wood, it's just 4 lines, but actually there is so much more if we're really going to represent the material as it is. Also trying to understand what they mean in terms of aesthetic, but also what are the things that you can do with them. Okay, it plays again. We also went around and looked for buildings that have been using secondhand wood. And this was very close to home. In Christiania, there was a facade being made from secondhand wood. So here we can see different discoloring, but also we can see kind of that maybe the details are not done as they should be. And there could be later problems with this facade. So actually, and this is how it perhaps should have been done, to minimize the material wasted, but also to be sure that there is good quality detailing that can ensure good performance. And then I hope that in the future there will be more buildings where we enjoy seeing secondhand wood that has not only a second life, but a third and a fourth. And maybe the aesthetic that we start looking at will be different, and it will be something that we live with and work with to make sure that that materials can last longer, just like these shingles here, or the last example. So I stop here, and I would like to invite the next speaker. Thank you.
So I'm going to try to share my screen, and hopefully this will work beautifully now. So finally, I'm sitting here in my kid's bedroom with Christmas lighting. And my name is Pasi Aalto. I'm the center director for NTNU Wood, and basically we're a, let's say, a cross-disciplinary accelerator of everything that has to do with wood at the university. And today I'm going to be talking a little bit something that most, at least architects, think are a little bit boring, which is sort of laws and regulations. We always think, oh no, God, that's so boring. But there's some stuff that we really need to prepare for, at least in the university. And I'm going to be talking based on carbon storage, which Olga already started on. But just to remind everybody about the carbon storage time frame is that really, even if forests grow up faster when they're young, and we cut old forests to make buildings, we're really looking at very slow, long processes. So basically something that is in the ballpark of 150 to 200 years before the new forest grows up to store enough carbon that we can sort of offset what we took out in the previous round. So just to give you an idea, this is Washington, D.C. 180 years ago. This was the society where architects were designing in. And this was what our sort of design speed has become, is that the buildings we build cannot go from this society to future. It's going ever faster. So there's actually no other way around keeping our building-based carbon storages except circular economy, or in this case, the reuse of building materials. It's very hard to do a design that is relevant in society for 200 years. So this is a picture I've been using for myself, try to get everything into click sort of in my head. So basically in the middle, we have in-use building, and it basically goes through two processes during its lifespan continuously. One is the building transformation, all the changes that happens to a building. So every time there is a functional change, something gets taken out, some materials, and some other materials are getting put back in. And this is the right-hand circle that becomes the reuse of materials. And that obviously also connects to all the other buildings and other processes in society where we reuse the materials. And also you have obviously new materials and the waste coming in and out. So this is sort of the circular part. And if we look at this circular part, basically it was never thought about when we made this construction products regulation, which is the EU law that governs what you're allowed to put in a building and what you're not allowed to put in a building. So this legislation is currently, at least in Norway, blocking most startups, big companies, everybody that want to do reuse. This is the law that's stopping doing it legally. So I'm going to go through some of this sort of framework, and I'm going to try to figure out some good ways of doing it, because the main thing here is now everybody knows that this law is old-fashioned, outdated, yeah, but it takes so long to change laws in the EU. So right now, this regulation is on hearing. The deadline is 25th of December. I wonder who decided that one. But you can already see in the aim that they're trying to make it part of the Green Deal and Circular Economy Action Plan. So this is something that everybody's aware of, but still, this is the law that blocks. So there's a link to the hearing. I hope everybody can join. I'll put it in the last slide as well. And this is where it becomes a problem. 2020 NTNU, where I work, we had several hundred students starting their 5-year studies in engineering, architectural, sustainable architecture, whatever. And basically by today, the reuse of building materials is illegal in most cases, or it's blocked by documentation requirements. By the time that they're done in 2025, reuse of building materials is most likely central to their professional work. So that becomes the question. How do we do the research? How do we actually teach reuse? How do we find real solutions? And in our case, we have a lot of faith on the design and build workshops because we see that it's quite easy to write a report about reuse. It's quite different in actually taking out 1,000 screws from existing cladding and actually feeling on your body what sort of effort it takes to reuse materials. And here's a sauna made in a bunker that we did a few years back, where we used a lot of reuse. We weren't really that aware of the problems with the legislation at the time, but we just figure out, let's try to build this. Another one, which we did a few years back in India, is obviously when you go abroad, there is no EU legislation. So basically you can do a lot. You can try out a lot of stuff. And finally, there's a little also sauna on a pier in the northern Norway. And this is also quite interesting, is that this is obviously not, a pier isn't suitable for a building. So this is sort of borderline if we could build it or not, but the municipality said yes. So here we go. But this is interesting ways of developing new understanding. So after this, we figure out that we wanted to do a more systematic overview of what we're actually allowed to do and not allowed to do. And this is sort of what I was thinking about sharing today, is the 10 solutions for guerrilla reuse of materials. And this is, first of all, this is based on Norwegian law, which is based on EU law, but your mileage may vary. The other one is we're talking about really gray zones of how far can you push the law. And basically we're looking at places where there's no high court rulings yet, or there's some ambiguity in the way you interpret the law. So these are sort of the cracks that we're talking about. So I wouldn't go out and say, oh, I saw a presentation, they said this, therefore I will do it all the time. So try to think of this as opportunities and discussion points and go from there. So the first one is that there's an exemption in the law that says that if your elements are produced on site in accordance to national rules and regulations, you're actually allowed to put them out without the performance documentation. So it's sort of just trusted. So basically, with students, you can build on site and make elements out of things, and that's okay, as far as we can see. The other one specific solution is that if you go for a custom build for a specific single building and you install it yourself, you can do stuff like a stairwell or parametric wall or something. This is something that has a huge potential in terms of how do we actually design reuse materials. We could actually take them into custom processes and therefore be allowed to reuse more materials. The last one is you can go traditional. So if you're working on a heritage building or a protected building, you can redevelop all the heritage techniques and learn as much as you can, and then actually take that learning back to normal buildings in 5 years' time. So you still have to follow the rules and regulations, but yeah, here's a nice example in the picture of us building a 500 millimeter thick wall out of sort of masonry wall, cord wall, out of logs, old logs. So which is interesting building process. The next one is really borderline, but basically we have a ruling that says that if you have a huge villa wagon, as it's called, villavagn, it's considered a building. But a lot of the law that they use to say that it's a building is that you can't register it as a trailer. It's 36 square meters, etc., etc. So I think there might be an opening for tiny microhouses on trailers that are registered. So that's a good place to develop reuse. Try small buildings, put them on trailers, and see how everything works. It's a bit gray area, but still. Then there's one which is really interesting, is that houseboats are buildings in terms of Norwegian law, but there's a lot of exemptions, and especially if the boat still works as a boat mainly, then you can do whatever you want. And there's also exemptions, so that if in the law for aquatic products, that if you do self-build research boats, kayaks, etc., a long list of exemptions. So here, for instance, we have a mussel structure that is sort of developed to put out into the sea with ropes, and it will grow mussels over time, and you can harvest your own mussels as a sort of private citizen. A lot of interesting things that you can do if what you're doing, it floats. And then you can go old school. So this is interesting interpretation, but basically the documentation requirements for all the products are from the year the product was first taken into use or made. So basically anything prior to 1950 didn't have any documentation requirements. So that means that as long as it hasn't changed, you can actually still use it in any building. It's only with the newer buildings that we get these requirements that you have to have all sorts of different paperwork in order. And then there's obviously the one that we are very fond of with the students, doing a temporary building. So pavilions, if it's less than 2 months, you don't need a building permit. That means that you still have to follow the rules and regulations, but there's a lot of leeway in doing these small temporary things. So this, for instance, in the picture is a small log cabin we did for a Finnish exhibition in Jyväskylä a few years back. And then there's the other part, which is the building products are only building products as long as they're permanently built into the building and they affect performance. So that means that anything that doesn't affect performance can potentially be reused materials. And then there's the older usual stuff that people say you should do furniture, art, anything that isn't a building, that's fair game. And finally, a lot of the rules and regulations are based on selling objects. So as long as you don't sell it, you use it within a project, within the different same owner, all these things, you get a lot more. So this is 10 very fast tips and tricks to sort of move around in the gray areas of the legislation. So now the question becomes, how do we actually develop this further? How do we actually work with this? And we started with this. This is a micro house that we're building now. And what you see on screen is 2 drawings. And these are the only drawings we have of the entire project. We have a trailer, which is 7.5 times 2.5 meters. And we figured out, okay, this is as much as we can build on it. The last third part you can change or switch out in the future. And this is sort of the whole idea of how do we design with reuse? We cannot design precisely. We always have to design in a way that you make a design rough, and then you have to figure out what fits where. What can you get hold of? The whole idea of precise design is sort of out of the window. So this is what we did. We did a rough design, and we took 4 students, got nice little gear from the local dump yard. And we sat there, and the law says that if somebody throws something in the bin, we're not allowed to pick it up. So we have to ask before everything gets thrown out, can we have your junk, basically. This is quite interesting. It took us 5 hours on a slow day to acquire all the materials for the whole main building body on the trailer. So the whole house. That includes main construction, flooring, panels, floor heating, anything that is sort of the main construction, except for the wind barrier, screws, and the prune for covering for underneath the heat foil. So this is basically 5 hours of work. I have never ever made this much value for my university in 5 hours ever. And this is us this morning. This is us with all our materials, with the trailer, building the base of the micro. So that it's all in elements, but I took a picture of the trailer and our material storage. And you can see, for instance, the insulation in the left is basically just a guy who figured out that he wanted to throw away 6 rolls of insulation. So it's brand new, never used, but it's getting thrown away. So this is also a question of what quality is the material you're wanting to reuse. And what we hope to gain from this project is we want to show that through the use of sort of the micro house on a trailer, this is a trailer we can register, and trying to build up more and more. We will try to build one micro house that is 100% reuse or throwaway materials, and see what we learn while we do it. And after that, we might start to get to the point where we can actually make educated guesses about how to implement this on bigger projects, because everybody's talking about huge projects, but we're not really trying out the small stuff yet. So this is sort of our approach to the dilemma of we really need to develop all the knowledge now, but the legislation is not really caught up with society yet. So we're trying to figure out small and maybe sneaky ways of getting to the point where we can teach this efficiently, and then make sure that we don't sort of slow down the process of developing this knowledge with 5 years in waiting of legislation, but we make sure that the moment the legislation is updated, we can get people out who know what they're doing in professional lives. So I hope this is a small introduction. I hope everybody could go and take a screen grab now, or probably share the link, but you can also just Google the construction products regulation hearing and try to figure out if you want to chip in your 5 cents in how we should do reuse better. So that's it for me. I'm guessing questions at the end, and I'm guessing San will give out the next speaker.
Excellent. Okay, so hi everyone. My name is Milan, and I am a PhD student at the Royal Danish Academy, formerly of Fine Arts, now just the Royal Danish Academy. I'm at the Institute for Visual Design, and my work is kind of located at the intersection of social scientific player research and game design. So I'm kind of coming out of left field for this entire presentation or project, but I hope to still be able to contribute a little bit. I'm by trade a humanities scholar. I first studied linguistics and literature in Serbia, and then I started working with games at the master level at the Aalto University of Copenhagen before joining the academy here. And today I will be talking about an area of research and an area of design that might be familiar to some of you, but maybe not by name and not in any sort of formal way. And that area is multimodality. And by the end of the presentation, I hope to be able to show you how some design principles for multimodality can be useful and can help you to kind of achieve better communication of relevant properties and information of the materials that you're dealing with and that you're exploring. So in the context of today's presentation, we'll be talking about wood mostly, but the general ideas for multimodality are applicable to any sort of material, whether it's physical or digital. So let us get started. So in essence, multimodality is just the use of several different semiotic modes within a single text or within a single discourse. So just to give you an example, I'm now using my voice to kind of communicate something to you, but I'm also using my hands to make gestures. And you can hopefully also see the title, the textual kind of information on the screen as part of my PowerPoint presentation as well. So that's already at least 3 different kind of semiotic modes. So the text on the screen, the sound of my voice, and the gestures that you can see, all kind of working together to communicate the same message. And that is the general idea of multimodality. So multimodality seeks to kind of offer a deeper or kind of more layered method of communication. And when you think about it, most, if not all, of the kind of methods of communication that we have these days tend to be multimodal because they frequently kind of include several different semiotic modes to contribute to the same kind of information production. There is another way to kind of understand multimodality, and that is in a research context. And there it is an interdisciplinary approach to how representation and communication work. And this is kind of where I come from mostly as part of my humanities background. So multimodality as a kind of research discipline draws on or kind of is based on 3 principles. The first one is that communication always draws on multiple modes. So as a general idea of multimodality is that all communication is multimodal. The second principle is that meaning-making resources are socially shaped over time, meaning that one kind of particular channel of communication means something one day and 10 years ago or 20 or 30 years ago, it kind of meant something different, also like in a different setting or in a different community or in a different culture. And the third principle is that meaning is orchestrated or kind of brought together through the selection and configuration of these modes, meaning that when we communicate, we choose particular modes, omit others, and that contributes to the meaning of the information or the text that we want to convey. So just to kind of briefly again go over it, this is these are maybe the 3 key terms in multimodality that are good to know before we proceed. So semiotic resource is one of the kind of key terms, and that refers to a specific either physiological or technological capacity for producing signs. So for example, a vocal apparatus is a semiotic resource because it can contribute to the production of sound. Muscles are a semiotic resource because they can contribute to the production of gestures. A keyboard is a semiotic resource because it can help you when you, to produce text, and so on and so forth. Kind of similar to the idea of semiotic resource is medium, and in multimodality, medium is just simply understood as the material form of the sign. So for example, lines on a paper, when you write reflections on a compact disc that your disc reader will read, flashes of light, and so on and so forth. And like I said, there's usually some overlap between semiotic resource and medium. The way to distinguish them very easily is to think about semiotic resource in terms of production. So they're kind of more related to how signs are produced, and medium is more related to how signs are distributed from one person to the next, or one entity to the next. And last but not least, we have the key concept, and that is mode. A mode is in multimodality and multimodal studies. It's a socioculturally shaped channel of communication. So it is an established form of communication that draws on certain resources, has certain forms, and has certain kind of structures and coherence to the way that it is used. Writing is a mode, gesture is a form of a mode, moving images when arranged kind of as a narrative are also a mode. Narrative itself is also a mode because it relates to a particular set of organizing events. Even though it can be kind of transmitted in different media, it still kind of constitutes a mode. So this might seem simple enough, or maybe not. I guess it depends on where you're coming from. But in reality, things are, of course, much more complicated. So when we take a look at an example of a multimodal text and fair warning, most of the examples today will be from the domain of games, because that's what I study and that's what where I kind of think multimodality is very, very clearly evident. When we think about multimodal text, or when we analyze them, we can see that there can be incredibly immensely complex. So for example, this is a screenshot from a game, Horizon Zero Dawn, made for the PlayStation 4 by the developers Guerilla Games. And if you try and kind of understand what's going on here, you can already see that there are many different modes that are being utilized to convey different forms of information to the player. Some of them are kind of maybe somewhat evident, even if you don't kind of have an idea of the kind of genre or the convention that the game kind of belongs to, or that the game is trying to communicate. So for example, you can see that there's something kind of like an objective here in the upper left corner. It says travel to Meridian. You can perhaps ascertain that this is your player character and that this is a monster or enemy that you have to defeat. So some of the ideas are kind of obvious right then and there, but some of them are much more kind of tied to the conventionality of the medium and to how they're represented as part of the genre. So for example, in the lower right corner, you can see a numerical piece of information that tells you how many arrows you have left in your quiver, as well as the kind of weapon that you have equipped. In the upper right corner, the number 12 indicates the level of your character. The number to the right of it indicates how many experience points you need to reach the next level. In the upper left corner, the number in the red kind of bar indicates your health points, and so on and so forth. So this is just a very quick example of actually an illustration to kind of show how multimodal interfaces and artifacts can be tremendously complex, both to design and to interpret or analyze. And as a result, some kind of guiding principles can be very useful in interpreting them and in knowing how to kind of communicate information effectively in a multimodal fashion. So one of the simplest distinctions that we can make is between multimodal input and multimodal output. And to illustrate this, I'll again use a game example. This is Nintendo's currently kind of active console, the Nintendo Switch. Some of you may have heard about it. So the Switch characteristically comes with these two controllers on either side. They're known as Joy-Cons. Here is the left one is blue and the right one is red. And each of these controllers has kind of specific input-output capabilities that transcend kind of what we commonly think of when we think of playing video games, because we tend to consider, the pressing of buttons as input and just visuals on the screen, maybe with a little bit of sound, as output. Well, for the Nintendo Switch, it kind of works a little bit differently, because the right Joy-Con, the red one, as you can see here, has an infrared camera that can, for example, be used when you're playing a game of tic-tac-toe with the AI opponent on the switches. So you can kind of register your gesture, and it can also register the distance from the infrared camera, which can be used as a form of gestural or haptic input. On the other hand, the blue Joy-Con, as illustrated here, has a form of haptic feedback that Nintendo refers to as HD rumble, which, according to them, is able to kind of simulate the difference between holding like a glass with a single ice cube in it versus a glass with 2 or 3 ice cubes. So it's kind of very delicate, very precise form of rumble, which is a kind of very specific, highly developed example of a haptic modal output. So that's kind of the one way to think about the multimodalities, kind of between the differences between input and output. Another way is to think about consonance versus dissonance. And consonance basically just means the integration of various modes towards a specific message that the designer or the creator of the communication is trying to convey. And this is an example from a game called Dysphoria by Anna Entropy. It is a game that has been kind of created to illustrate its author's experience with the gender transition. And you are playing in one short segment as a kind of a Tetris piece that needs to navigate this yellow wall, but because of the shape of the piece, you cannot kind of make it quite through the wall, but you get stuck. And in the game, this is accompanied by the text that says, "I feel weird about my body." And here we have an example of the procedural mode, so kind of controlling or navigating this Tetris piece And the textual mode, the message that says here, I feel weird about my body, coming together to kind of heighten this idea of not fitting in or not being able to kind of find your way through a place, which is what the designer kind of intended to signal to their audiences. Conversely, we can have the idea of multimodal dissonance, which is when two modes kind of clash or conflict with one another, and the information that they're trying to convey as a result might be a bit more muddy, or might make the audience kind of work in depth and think about its meaning or its significance. This is a game called Papers, Please. It is made by a single developer, also by Lucas Pope, and it takes place in a fictional Eastern European country of Arstotzka, where you're working as a border security officer and you're checking the documents of people who are coming into the country. You can let someone in, you can choose to let others, to kind of forbid entry to others. And you can kind of usually encounter at least two levels of dissonance here. So there can be like an informational form of dissonance, for example, certain numbers not matching, or certain kind of description not matching with the actual visuals of the person who is trying to gain entry. But more importantly, you can have something called, that I can kind of refer to as performative dissonance, where the game kind of instructs you to let a certain number of people in, but you know, none of the people who come in have necessary documents, so you kind of don't feel like that is something that you can do. So the goals of the game are, or the procedural mode of the game is in conflict with kind of the information presented audiovisually on the screen. So that is kind of the idea of consonance versus dissonance in multimodal design. And if we move on to the to materials, we can kind of see how this might work in practice for kind of communicating information about materials. And I've divided this into kind of 4 subtopics, basically, that might be useful to think about when trying to communicate some material information in a multimodal way to your audiences. So, for example, multimodal presentation can greatly aid when communicating specific material properties, as reported, for example, by Martin and colleagues. They did this research where they basically recruited some people and got them to experience 3 kinds of materials, so 4 leathers, 4 papers, and 4 fabrics in several kinds of fashion. So visually plus with an audio feedback, and kind of haptically, so they got them to touch the materials as well. And what they found is that, for example, sound was very, very helpful in communicating tactile qualities of the materials, like smoothness and softness, that could otherwise not be communicated visually very well. So a tip for kind of starting off communicating about your material is to consider what specific properties the material has and which of them you want to communicate to your audience. Yeah, I just will quickly run through the rest of the slides, and I hope that's okay. So the second idea is mode pertinence. So basically just consider which modes are relevant for the information that you want to kind of convey. Some modes, as you can see here, for example, work better with a certain kind of information, whereas not so good with certain other kinds of information. And focus on those that work for you or for the properties of the materials you're dealing with. The idea of narrative is also super important. So it is tempting to focus on the present state of the material, but please try not to forget the past or the future of it, because that way you can tell a story to the audience and they're much more likely to kind of remember it than if you only just convey a bunch of facts. And last but not least, do keep in mind what the audience of your communication is. Because not everyone is either interested in or can understand everything you know about the material that you're trying to communicate. So basically know who you're talking to and adjust what you're saying accordingly, because not all modes are equally relevant to all audiences. And that's it for me. Thank you so much. And sorry for running a little bit over time. I'll stop the screen share right now.
Yeah, there's been some really inspiring and interesting things said so far. So I hope this is going to be interesting as well, although again, it's a little bit off topic maybe. As you can see, I live in a quite picturesque part of Tuscany, and this is all sort of the local landscape. There's a a village, and our house is the one with the circle. And the thing that has interested me most about living here has been an attempt to be as self-sustaining and to produce as much as possible of what we consume. So some of the things that have already been mentioned about the cycle of a product and using the product that you find rather than wanting products that you can't necessarily have are things that have been part of this practice. And the other thing I think is interesting is right now, I mean, I've always worked sort of remotely and not had that much contact with people. And right now, I think that is quite a significant reflection on whether it is possible to live remotely and to be involved in conversations that are fairly diverse from what would be the immediate prospect in front of us. Anyway, the house is there, and this mass to the right in the photo of the house is a big bamboo plantation, and it was a problem. It was, you know, we talked before about waste flows, and this in a way is even worse than a waste flow because it's self-producing and it steals the land. So I was interested in cultivating olives and vines and vegetables and fruit, and this bamboo plantation was taking the land away and is expensive to control. I had to spend money to get people to cut it for us, and then I had to deal with a product which is, you know, a large volume of material, and burning it or poisoning it weren't really options. So some of the things I've done have been to do with looking at your resources, looking at, you know, negative features of your surroundings as a resource. It's a feature, not a bug, basically. This is the bamboo. It grows pretty fast. Anyone who knows anything about it, it's a grass, not a wood. So there again, it shouldn't really be included in this discussion, but you know, I work with the material that is most available to me. It grows about 15, 16 meters in a few months. And as I say, it's very invasive. So it takes a lot of land, and we do have to cut very regularly. The first solution was to use the dry bamboo, cut that into small pieces that can go straight on the stove. And that means, you know, I'm able to heat the house to an extent and also to do the cooking. Bamboo burns at a nice high temperature, so you can get the pasta water on and boiling fairly fast. That's an advantage. And these were kind of interesting positive byproducts from the experimentation of using what was around us. Early attempts at building. So I've come from I studied graphic design. I've no experience in either architecture or engineering, and no carpentry competences. So this is what someone who doesn't know all of that can build. And it looks like, you know, typical building by fairly primitive rudimentary skills, bits of string, bits of wire netting, and a bit of thatch on top. This was a chicken house. And then another early construction was the line to dry the clothes. Here again, if you don't have a conventional training in building or construction methods, you end up using the sort of methods that are easy with materials that are very, very cheap, and budgets here have always been on the small side. Yeah, neither of these first efforts were particularly successful. The chickens didn't much like their house up in the top of the bamboo, and the washing line was such a, you know, it was so lightweight that the wind just blew it away. So neither were particularly good. And I was encouraged to study a little bit more about what bamboo would do. So there again, the list of things that you can't make with bamboo is probably very long. The list of things that you can build may be shorter, but it's probably the more interesting list to look at when you're thinking about a product that is otherwise not easy to work with. Here, the tool that I'm using is well, is available on internet for $20, $30. So very low cost. And with that, you can split the bamboo into sections, in this case 6, which are very flexible. The green bamboo is very soft and supple, and so it's a good weaving material. And the style of weaving here is the 3-direction, the triaxial type of weaving. Because it has triangles and hexagons in the weave, it's one of these, it's the friction between the elements of the weave make it very stable, and a small amount of material, this probably a panel like this would take 3 or 4 canes of bamboo. So a small amount of material, you're getting a reasonable result, you know, lightweight and fairly fast to produce. So flat panels can be produced that way, and flat panels can also be bent. That's an advantage for gardeners, obviously, because you're not only using the floor plan, you're also using the vertical space, so you can get more crops, more product with you know, a fairly limited amount of space, if that's the situation. Here again, the shapes are still cylinders, but it's still a flat weave. So just the hexagons and the triangles can be bent into various shapes, which become reasonably functional for the, you know, gardening, small scale agricultural projects. Then my experimentation led to trying to be a little bit more commercial, so making larger structures, also learning from basketry techniques, using the style that you can see when baskets are woven. Some of this I just borrowed the traditional way of weaving and scaled it up to make larger structures, and bamboo lends itself pretty well to that. These are probably 2.5 meters diameter in a shopping mall. And this is one of the larger things. So this was the outcome of a workshop with participants who had no experience. And there again, the triaxial or kagome mesh is very, very practical, efficient way of producing a largish structure. This one's about 8 meters in diameter. Couple of days work with participants. So the issue with this sort of structure is that it has to be built on location. You can't transport it, obviously, when you get to this site of this kind of dimension. So then one of the issues I've been working on trying to solve is to make things more transportable. So basically looking at how things can be compressed. And here again, if I assume that this style of weaving is similar to a cylinder, which is deformable, as well as weaving, I'm using nuts and bolts to connect the elements, and then they can be, the sphere shape can be deployed into a cylinder. So it's quite compressible and would fit on the back of a truck. So that helps with the transport issue. And another aspect, as I say, it's very small a practice, basically a one person practice. So I have to look at ways that a building can be made by me, or me and one of my children if they're around to help. And I think one of the best things that I find about having the bamboo available, having it, you know, at a few meters distance from the house, is that I can be cutting the bamboo in the morning, splitting it and making something by the afternoon. The plant to product cycle is really very minimal. And for somebody who has, you know, maybe little patience as I do, that's a very satisfying result. I can have something that's almost habitable size in a matter of a few hours. So being able to experiment is a great luxury, but as I say, the bamboo grows itself in great quantities. So the investment that I'm making is only in question of time. It's my labor that I'm investing, and it's rarely a cost of anything more than a few nuts and bolts little bit of hardware, not much expense for tools or anything like that. So there we're using pieces that are probably 5 meters long. Here again, it would be, tricky to transport in the expanded situation, but it's also fairly easy to compress. Yeah. So that's what I've been spending my time on this summer, making a few of these structures, then leaving them out in the sunshine and the weather just to see how the material will behave when exposed to the elements. Generally, the advantage with woven structures in bamboo is that as they are made in the green state, they're quite heavy and a little bit floppy, but then the sun and the wind dry out and they lose quite a lot of the moisture content, and they become lighter and stiffer. So that's all beneficial, and that's good free stuff that comes along. This was last year. We did a workshop in Sao Paulo in Brazil and got a nice write-up in the New York Times. So it's a little bit of recognition. But I have to say, as far as commercial applications, that aspect of the work practice is not so successful. It's quite hard to sell things that people assume are made of, their assumptions about the material are that it's a very cheap material. And I think this is something that the second speaker, sorry, touched upon, that, you have to be careful how the public perceives your material. If they feel that you're selling them something that ought to be very, very cheap, then it's hard for them to accept that it has an innate value that is not just to do with the material. And then another way of making things transportable. So if I'm working on a workshop, I generally have to take the materials in a suitcase. So the length is defined by the dimension of the suitcase. Things have to be broken up into shorter elements, more modular construction, but the simple technique, the reciprocal node or the nexorade, where you drill 2 holes in the end of each piece of material, works pretty well for that. And it's a good didactic material. Students can experiment with this sort of connection, which in turn lends itself to various geometries, various building styles. And once again, I think the speed and the ease of the learning process is generally an advantage in workshops. So just the nuts and bolts again. As I say, the connections can be 3, 4, 5, 6, even 7 pieces of bamboo can be joined at the nodes, which allows a decent amount of variation in the geometry of the building. And that was the competition entry at Amsterdam, the IASS Spatial Structures Pavilion competition in 2015. So with pieces of bamboo that were about 55 centimeters long, the overall structure was 4 meters diameter. And by putting Velcro on the bamboo, it's very simple. As I say, I prefer the primitive approach, but sticking Velcro on the bamboo and then putting Velcro on the lycra patches means that you can make a cladding for the shapes, which defines the form a little bit better. And the stretchiness of the fabric also gives you the good definition of the hyperbolic curves, the saddle shapes. And then this is more recent, so I'm still looking at what shapes can be made by, keeping the straightness of the material, how much you need to bend the material, whether it's better to bend the fabric and keep the material straight, or whether I can bend the bamboo to a greater extent. This one was for an exhibition near Barcelona this year, working on the different geometrical, similar to minimal surfaces. This is another one. So in this case, the lines of the bamboo are very much more curved, but the principle is very similar, just attaching same sized elastic lycra patches to the material. In this case, they're squares and hexagons. But the tessellation is basically a hyperbolic tessellation, so that you get this kind of very porous structure with a lot of voids and holes in it. And putting the patches on with bicolor patches means that you get more definition of the surfaces. So it's easier to talk about the geometry of the minimal surface in this way. But the materials, the bamboo and the stitched on jersey patches work quite well to give definition to that. As I say, I've worked with bamboo because that's what I have. And recently, we've also done some workshops where bamboo has not been available. So then we've looked at the possibilities of varying this material and transforming it using, in this case, we were using plywood pieces. So there were, here again, they're colored on one side to give a definition of the surface, but these are basically a thin plywood rectangle connected with reciprocal node connection. Each of the vertices are connecting 3 pieces of wood, and looking at the variations of the different combinations within that fairly constrained vocabulary of elements. And then the last couple of slides are just to say that, it's been interesting to be able to open up my very kind of limited approach with the competences of, a failed graphic designer and basket maker, but the contact which I have had with both the academy there in Copenhagen and this one is the EPFL mechanical engineering faculty in Lausanne. Just exploring a little bit more deeply the possibilities of the various weaving styles and how they relate to topology and more advanced engineering subjects. This guy just defended his thesis at MIT and he's gone on to Harvard. We're hoping to publish this in a few months' time. And that one is with Phil Ayres from CETA in the architecture school there. So here again, the bit that I can deal with is the very simple modeling with paper, modeling with bamboo to set out the principles of the weaving system. And then people who have better simulation and digital skills, obviously, are able to make that into more of a formula, more of a digital vocabulary, where they can then prescribe a weaving pattern and they can design it in the opposite direction. So starting with the image that they produce from the code and develop it to something that I can produce, or we can work in the opposite direction where I produce something and then we analyze it and work out the pattern from the model. So it's been fascinating for me to have this opening and the sort of doubling of the approach, just by in the past it's been possible to travel to these places. Recently there hasn't been so much travel, but luckily we still have the internet and the contacts can continue, and makes life basically a lot more interesting, even when you live on the side of on a windy hillside in Tuscany. So I think I'm done there. Thank you for listening.
Okay, so hi everybody, good afternoon. My name is Mark Hughes. I'm from the Department of Bioproducts and Biosystems at Aalto University in Finland. My background is actually in mechanical engineering. I switched to studying wood about 25 years ago. I just found it a fascinating material. But anyway, yeah, so cascading wood, and Olga gave a really nice intro to this, and I'm really happy to kind of try to maybe sort of give a few perspectives on where we are with wood cascading, what can be done about it, and really, is it going to always be a fantasy, or can we actually bring it into practice, and what do we actually need to do to make it a practice? So yeah. Maybe a little bit of background, and I apologize if you've seen this earlier from Olga's slides, but what we do know is that the building industry is responsible for about half of all materials extracted from the earth, which is a phenomenal amount, and it's something of the order of about 50 billion tons a year. Also responsible for almost 40% of CO2 emissions and around 36% of final energy use. So it's a really a sector that has a huge impact on the environment, and along with the huge impact, there is also a big chance to make an impact if we can make some changes to these kind of impacts and start to use materials more effectively and efficiently. Then perhaps we can reduce the overall impact from not just the sector but globally. So it makes a good sense to do this. And wood, of course, is one of those materials that people are talking about and have been talking about for a long time as being a good material because of its characteristics. And for example, we know it has nice thermal properties. It's good insulating material. It's from a tactile perspective, it's also a very nice material to actually to live with. It's nice underfoot, nice to touch, has very good haptic properties. Of course, if you live in an environment that's mediated by wood, it does affect the indoor air quite nicely, and that can have a positive effect on one's well-being and also one's health. The main thing that's when it comes to the environmental side, of course, it's the carbon storage potential, and roughly half of the dry mass of wood is actually carbon. So a kilogram of carbon basically equates to about 1 3/4 or 1 2/3 kilograms of carbon dioxide is actually required to if you like, to synthesize wood. And of course, the other area is that if you're using wood in place of another material like concrete or steel, then you're not using those materials, and in doing so, you're saving the emissions from their production. This can be quite a significant saving as well. So there are many good reasons for actually utilizing wood or wishing to use wood. And whilst it's being used significantly in many areas, I mean, there's still a lot of room for further expansion and use of wood. And actually, Olga mentioned this paper that appeared earlier this year, looking at the potential of buildings actually acting as a global carbon sink. So by utilizing wood as a construction material in mid-rise urban dwellings, then and buildings, it could become a global carbon sink by using more wood products. So there are good and justifiable reasons for wanting to use wood to a greater extent. So we do certainly need different mechanisms, incentives to use this, and we've been involved in work now to try to find ways to incentivize more wood construction. Surprisingly, there's a lot of inertia from the construction sector, and they don't really want to switch to this new material. So it takes time. But I mean, if we look ahead and look at the resource base, which is of course the forest, if we do roll out much more wood construction and we utilize wood for other purposes in the bioeconomy, so for the production of chemicals, for polymers, plastics, etc., which are also good. It's also good to produce these materials from wood. We may end up in a situation where actually we have a deficit and we actually start to extract materials from the forest, and this will of course then lead to further degradation. So we have these two competing aspects, and there's already is a lot of discussion around this. How should we deal with this? And of course, one way of helping this is to think about how do we utilize the materials more effectively. So how can we maximize the substitution and storage potential of wood products, really without compromising the sequestration and sink potential of the forest. So this is really something that's really needs to be thought out. And it comes down maybe to resource cascading, or this is a potential approach. So resource cascading, probably many of you have seen something that looks something like this. The idea of resource cascading is rather than using a conventional approach to materials, single-use materials use, where we use a material for a certain period of time and then dispose of it. We maintain that material at a high level of quality for as long as possible, and then perhaps reuse it maybe through several product life cycles until eventually it has to be disposed of because the quality has dropped to such an extent that it can no longer be used any further. But this is the kind of the idea behind resource cascading, and people have now been looking at how can we do this with wood. And this is something that I became interested in and involved in about 10 years ago, maybe a little bit less than that. But and we started out, I had a very talented master student who was an architect from Japan, and he was also very interested in this concept. We talked about this, and he decided he would like to do a study. And we actually went and followed a demolition project in southern Finland, and we started to categorize the material that came out of it. And this was actually rather an interesting process to understand what could actually be recovered from a building, even if it was demolished in an existing manner. I'll come back to that in a moment, but maybe a little bit more about the resource cascading. So of course, a lot of wood is being used, is going into buildings. Something of the order of 900 million cubic meters of wood, sawnwood and wood-based panels is produced on an annual basis globally. I mean, that's a colossal amount of material, quite frankly. A lot of this, of course, not all sawnwood and wood-based panels go into construction, but a large proportion do. So a lot of the carbon that's locked up in the forest is being transferred to the built environment. And this is a kind of an increasing resource. I can't say an ever increasing resource because, of course, buildings are demolished and the materials come out, but it's an increasing source or resource, if you like, that we could tap into more. And this is the idea behind the cascading. What we're interested in is, and what we're doing at the moment is trying to characterize this resource, to look at the materials flows, to understand how much is available. And there have been many studies like this done. A project we were involved in a few years ago with partners in Austria and Germany. They did some work to understand how much was in the Austrian building stock, and around 30 odd million cubic meters of wood were embedded in residential buildings in Austria, and this is predicted to increase to almost 50 million by 2100. We've just done some work now in Finland, and we've kind of estimated or calculated that there should be something like about 17.5 million tons of wood in purely residential buildings alone. That's just in the structure, not in all the exterior cladding and so on and so forth, but just in the basic structures. So there's a very large stock of material that could be utilized for further applications. And ideally, what we would like to see would be something like this, where we have a kind of a cascade chain, where we would, first of all, we would reuse solid wood and veneer-based products like laminated veneer, lumber and plywood, maybe through several lifetimes in that form, before breaking it down into particles and using it in particle board. And after the particle board has reached at the end of its life, then perhaps we could then break it down further into the fibers and produce fiber-based products, paper and paper products and those kinds of things. Before yet again breaking it down and recovering the chemicals that could be used for making glues and plastics and so on forth, before eventually incinerating. What we do today is this: we go straight from material that has very good utility, very good potential quality, and we chip it and we burn it. This is what we would like to see. Try to retain this at a higher level for a longer period of time before, either through various cascade chains or directly then to incineration, but at least maintaining a higher value for a much longer period of time. So that would be an ideal situation. But of course, when we look at this, there must be a problem, otherwise we'd already be doing it. And the problem is this, which is a kind of a typical picture. If you go to any part of Europe, Spain, France, and you go to a waste wood reclamation site, you'll see something that looks a little bit like this. Lots of wood that is often broken, very mixed in dimensions, often containing lots of paint and varnish and other materials, nails, you name it, it's there. So there's all sorts of debris and contaminants that really does limit the material opportunities for recycling and for reuse. If we look in a bit more detail, we see this is the kind of thing that we see in the wood, nails, of course, and I have quite a lot of practical experience of reclaiming wood. Even this last weekend, I was removing nails from pieces of used wood to reuse in my house. And nails are not as easy to get out when they're old and rusty. Also, you see a lot of other materials, foams, styrox and polyurethane foam combined with nails. So it makes the possibility of recycling the material much more difficult, much more challenging. So this is what typically happens, and this is actually a photograph taken from Spain, part of our project, one of our project partners. But if you go to a reclamation site in Finland, you'll see something very similar. Basically, the wood is chipped into small particles. So all that potential utility from the material has been lost at this stage. Because of the contaminants, it's very difficult to reuse this in any material form. It can't go, for example, into particle board because of the contaminants there, or the potential for there being contaminants. So the only option really is to incinerate it, of course, with the energy recovery, but we've lost that opportunity for reusing the material. It doesn't necessarily need to be like this. I mean, it can be done, and this is the work that the student did some years ago, Daishi. He went and actually pulled out some samples of actually fairly good quality material that could be utilized. I mean, it could be much better still. I mean, this was just a standard demolition process, but it does show the potential to actually recover fairly useful pieces of timber that could be either reprocessed or even reused in this form somehow. Maybe a great example of how wood could be utilized, or how wood could be reclaimed from buildings is the traditional log house constructions in Scandinavia, the Nordic region. They're eminently suitable for deconstruction and for reuse. These logs, this is a photograph I took over the summer in the Åland Islands of a wooden log construction that had been dismantled and put under a shelter here just to keep the weather off. But clearly it's good for recovery, high rates of recovery of good quality material that could be either reprocessed or could be even reused in this form. I'm not advocating necessarily that we go back to log construction in this form, but at least think of some of the principles behind this could be something to take forward in the future. So talking with demolition companies here in Finland, there's nothing technically that prevents deconstruction of buildings currently, apart from the economics. The economics don't stack up at the moment. And this, of course, then limits the cascading opportunities for wood. If wood is demolished using very invasive mechanical means, it's broken, etc., etc. And also the construction methods that are currently employed make it more challenging to cascade the material. So we've been talking quite a lot about how could we build, and of course Olga was talking earlier about how do we actually build buildings now with disassembly in mind. So this is something that I think needs to be advocated in the sense that if we can recover greater amounts of material, this could be a good way of then promoting cascading. And this is something we're actually looking at in one of our current research projects, the In Future Wood project. So just some final thoughts, maybe to sum up. I mean, what we do know is that building construction is going to take up a very, very large proportion of the remaining carbon budget, which is pretty limited in any case. So we have to do something. Wood, we know, will have a positive impact in terms of sustainability, particularly in the area of climate change mitigation. We've just done some modeling work to look at carbon storage. The simplest way of keeping the carbon there is just to extend building lifetimes. If we can do that, then that's part of the, at least from a materials perspective, that's part of the battle won. We can affect the sustainability by better reuse and recycling through cascading, and this is something that needs to be embedded as soon as possible. And of course, the reuse and cascading recycling can be supported if we have design for disassembly, so that the material can be retained at a higher level of quality when it is actually recovered in the future. And we should also really start to think of buildings as material stores. This is a very valuable material that we need to maybe rethink our ways of looking at materials. I'm an engineer, so maybe I need some help with this. And maybe just finally, this is a picture I took earlier today from my own house. It's part of the log structure. Old logs, there's good evidence that these logs have been used before. The house has been standing for 100 years so far. It's looking in very good condition still, and hopefully will continue to look in good condition for many years to come with a bit of care and attention. So with that, I will close and thank you, and we can move on to the next speaker.
Thank you for being part of this very nicely curated seminar here. I'm really happy. Thanks, Olga. So it seems that like there's like different aspects from every side. So, and like maybe I'm the one who's kind of bring more the digital and tooling part in it. Although I think we are at CETA not only tool makers, but we are definitely makers, and we actually try things out. So what is CETA? CETA is a research center here in Copenhagen. Alison introduced a bit. It was really a joy to collaborate with you, and we're around 20 people now. We're looking in mainly new material process here, testing out metal forming, CNC knitting, looking at robotic fabrication as a way to make individual and adaptive and ways of producing. So like thinking about how we do things and how can we get feedback from a material into the tool making and into the fabrication. And we look into like data streams and gathering data to enable this feedback. Here, work from Tom and the InnoSham project, but also like here other projects with Kieran Timberlake, where we kind of monitor long-term behavior of materials to feed this and find out what is the design systems for doing this. We work in larger frameworks, like across a large set of topics. A lot of them are having photos on biomaterials and production with them. And for sure, as like introduced also before, and like our remit is really into okay, how can we erase that we have too much of some stuff, as for instance, waste plastics in the oceans, and like save on other materials where we are kind of soon going to be running out. As many, our kind of focus is as well on the bio-based material, which is kind of pushed forward as a way to kind of like remedy some of the problems that we have on climate change and material depletion. And so we kind of look here into different directions. One is like the kind of living materials as fungi or biological kind of cold inhabitants of our space, growing materials like cellulose and other like materials, and then the harvested, which is timber, which I'm going to talk about today, like as materials that we are finding, which is most closely to our current practices as architects and engineers. So when looking at timber, then like what we look at CETA and especially is like the understanding of how does this fit into actually our current production chains, and like what is it when we work with timber. And so like our underlying model for this is actually thinking of that we are not architects alone or engineers alone or fabricators alone, but that is kind of like a chain of like events and people who kind of give data or information from one to another. And like our remit since actually the beginning of CETA has been that this is like considered in architecture a one-way linear flow from the design idea to the production and to the making, and that what is really needed is like a sense of feedback between those different levels to actually understand it. And we think that this is especially important, like when we're thinking about like the upcoming circular economies, etc., which are inherently interwoven and where you cannot just dictate something which is like 3-4 steps further down. It don't account for the impact on CO2, etc. And we see that like our tools in architecture and engineering are actually not yet at the level that we can take in feedback, and that we are still working on this assumption that we design something with the user, with engineers, and then down the line it's going to be produced, not caring really much or having no insights actually into how it is going to be used, demolished, etc. So there's a really big lack of knowledge, which is just coming up obviously everywhere, but also then of like similarly like of tools to enable designers to think actually of this. So like this is what like has been called as a digital chain if you look at the data, and so in the this kind of the world we are working on, and like the model that we think of design is actually happening. So oops, so and what does it mean, for instance, like digital chain here, like the kind of exchange between the material, the fabrication data created at the fabricators and the design. So how can we inform design models about like the downstream fabrication, use, operation, and maybe disassembly? What are kind of the models for this? One of our research investigations here, reciprocal structure. And for sure also like how do we reduce complexity in materials, like the really nice finding in timber that you can make really complex joints and integrate a lot of like complexities that you usually would add on with additional material joints, etc. And you can just really put it into one material, so you can integrate complexities in it and use prefabrication to do that. Like, so this is a base for timber for manufacturing. We've been looking a lot into how do you actually then work with like those complex behaviors that are when you're looking downstream. So like, for instance, the behavior of material under bending, your active bending is like one of our like research areas where we kind of need to tightly integrate simulation and design. And we see this as a model of a future design tools, which can, for instance, also encompass like ideas about life cycle analysis, deconstruction, etc. So to kind of inform like design decisions and evaluate those like runningly, even in early designs. And then finally, like looking also into materials which are kind of more unconventional here, working, for instance, with branches and found materials as something where you have like a library of really interesting shapes, which could solve like your production, so you don't need to kind of make, for instance, complex building elements by gluing or something similar, but you can actually find them and you kind of create a library of elements and you can start to design this. And so here's some examples from early workshops. Now I see just like almost 8 years ago, but like thinking that there is a material stock around that you can reuse, I think is very interesting and very up to date. Like thinking especially from like the project that Mark just showed, so where you think you have like all this building stock, you have like a library of elements, how do we use them and reuse them in like for our new buildings? And so here looking at found and usually like also considered waste wood and from branches. And this went then further into some of our students here, master student in 14, like Christian, who was looking how can we actually scan a whole of forest and like extract the knowledge that is inside with like this kind of scans about geometries, which could then help you to kind of build like a small house in the forest with local material. So here again, the kind of library. So, and Tom Swillens and others in the InnoChain project and have also like investigated how can this, what we kind of think of in like academia and like small prototypes can be scaled up, and how can we kind of create like a sharing between methods that we in academia create towards the industry here, collaboration with Blum and Lehmann in Gosau in Switzerland. So if wood is so great, what is then the question? And I think like here, some kind of observation maybe from a different point, similar to what other speakers today have been shown. So one, that material is not unlimited. And so just like this study here on the left, like about how we actually using more and more of our forests, and how like in the last 15 or 20 years, like there is an increase in like the use of wood, and how this means also that you have like younger forests. And like, so now we've been hearing a lot about carbon sequestering and like carbon storage in buildings, but if our forests get younger and younger, they can actually store less CO2 than old forests. So, and if they are chopped off earlier, then they are even saving even less of our CO2. So like all the climate models have to be reconsidered when this is happening. So when we are just increasing the use of wood, which is a limited resource. And then secondly, also like similar to others today, the realization that we lose really a lot of material on the way from the tree to the build element. Like Olga had something like 40 or 50%. When we did our investigation for research project, we found that we like lose up to 80% of the initial material, the biomass, until like a tree becomes a like glulam elements. So there's like a real need to reconsider, and like there's also huge potential, not just in reusing material, but also in the how we are using material. And like there's this, like this is like our one of the bigger questions in our current research. And like we think a lot of the problems that why this is happening is like that we are not used to kind of like think deeper into the material. So we kind of are used and trained very much as taken materials as something which is given, with something which is found, whether it's like steel on the shelf, marble in Carrara, or graded wood that we just buy and we say, okay, we need a certain wood grade, we get it, and then we build it. And like, so we kind of are not really inclined to kind of think as material as something which is not necessarily of top quality and totally homogeneous, as like a lot of our kind of textbooks and also all our rules, as Pasi has shown today, actually require. So in CETA we have, despite like a lot of like our thinking is more about material as something which is designed and which can react to local affordances in terms of performance and like the environment they are situated in. And so like informing this, we have been looking a lot on like the timber and like how what actually happens from the tree when it's kind of chopped or when it's grown in the forestry up until it becomes a product. And so this tree to product workflow is actually something which has been researched for long, and like where the forestry industry has for sure put a lot of effort in, also a lot of EU project on kind of digitalization of them, like the idea of like the integrated forest management, harvesting, and sawmill and product making. So, and like to create like a product chain. And we've been investigating this and seeing a lot like a potential for this actually to kind of link this tree to product, like not just like to the sawmill, but like further on to product. And we think like the kind of outset of this is actually there and can really also inform like circular thinking, where a lot of the tools of investigation sensors are actually useful also for kind of reuse these things. So first of all, like what's happening in forestry is that there's like data is gathered on all levels from aerial to satellite to 3D scanning. There are like huge databases of like forest on kind of small level or also national levels, which kind of say where which like tree is living and when like it was grown and when it's be harvested. So there's like a more and more intelligence actually coming into forest management, but also then directing harvesting, so selecting harvesting instead of like clear cuts, etc. And like companies are investing here into intelligence, so like to make the people who are deciding which tree to shop actually more informed, more linked to the product that they are required, or even going so far to have like autonomous harvesting machines, like which kind of roams through the forest, informed by data gathered locally through scanning, or to kind of like data which is gathered beforehand on an area level. And then like when it comes through several steps to the sawmill, there we also see like sensors in sawmills, which for instance like here is CT log by like understanding like through CT scanning like the inside of a material here with a clear idea to optimize the yield from like a harvested tree and to steer it towards like higher efficiency in those sawmills. However, like in all of the tree to product thinking, like then it actually stops here, where the product is not a building or a piece of like furniture, but it's like a piece of graded wood, which is then shipped out, which has to be homogeneous and good. And so like there, around 50% of like the material is already lost and becomes then usually shop wood or paper pulp or something like that, and then releases all the CO2 way earlier than it. And so like on a speculative research, we have been thinking of, so how can we actually connect like this forestry wood production chain with kind of our digital chain that we are working on in architecture and engineering. It's kind of how to find the convergence between those two levels. How do we create something where kind of information about the raw material actually informing the design and vice versa. So we have two projects here. We've been looking into this, and one is like the raw lem, like investigating how you can actually create this link and what the potential is, for instance, for the wood, and like for the kind of a glue lem of a certain performance. So we this on the left here is like on our first humble prototype, looking at glue lem of like different kinds, where kind of we're kind of linking here like there's a sawmill to the affordances. These are like kind of the design, also the outcomes of a CT scan, like the kind of shifts, like as it cuts through a piece of log which runs through the CT scan in like 4 to 5 seconds, and then like the understanding of the inside of a tree is created. And we can then use this data to qualify and rate our material before it is being cut and inform our design. So like the idea then here, it's very simplistic to say, okay, we need in certain areas of the beam like good wood, for instance, where we have joints, and we can have like really not so good wood in like places where there's, for instance, low kind of performances or like needed. So similar to a beam where you have like the top and the bottom has like to be really strong and being good in compression or tension, but like everything which is happening in between of like a beam doesn't actually need to perform as well. It's really more there to space out. So how can we use this and like activate this here to kind of create to use like less good wood in our beams? So what we do down here is like that we have like different views onto our model here, like this glue lem structure, investigating the structures through structural simulation, the forces there. We investigate the making and the needs for fabrication here, especially as it's like bended wood. So like the curvature ratio and like what kind of forces are coming in the bending process there. And then finally overlaying there the joint locations and like the quality of wood. And then you kind of have a combined mapping. This is now a very focused view on what like a timber beam has to be. There can be many more layers, but it's more to have like an outset of like an idea how like this kind of requires or kind of creates some affordances for like a beam, and how this then can be met with like a library of like of wood qualities which we find in one or several of those beams before they're actually cut. And so there we kind of use some kind of matching algorithms to kind of like take those two layers or two views and like match them and inform the cutting and fabrication afterwards. This is then the outcome of like a second prototype where we kind of had like more automatization, less of the hand making that was necessary for the first one here. And so we are kind of stepping forward like in very baby steps and towards like figuring out what is the kind of technology, but also what's the kind of design space where we are kind of still see quite some potential there. And the second project I want to kind of quickly show is like the project called DeepSight. It's also a visualization project here, and like then thinking of, okay, so how are we actually working with this huge amounts of data that we get from CT scans and similar, and where we kind of find that all the kind of the matching just of like the found volume of data in like this library of existing like beams and trunks and the design requirements of like one beam or several beams or a building is just like a huge task where you kind of need to handle large volumetric data. And so how can we actually access this kind of material level of understanding which we get through CT scanning in design processes? And so here like our the views through like a little trunk here and just seeing, okay, what nature is giving us when it's kind of developing those branches and like the kind of the quality of wood and the fiber setup which is in there. And so to activate this is like the question here. And so how do you go from like a nice CT image which shows like only the density of like a beam, but to something which we can activate in a more abstract level in design. So here different views here from the computed tomography image or the density image on the right to something like mesh or other surfaces which are more accessible in CAD tools. and like different tasks here on having like a relatively fast design tools to and analyze, for instance, the contours or detect where's the place, so like the center of the tree in those data sets. We're looking here at several, like in this project called DeepSight, like in several tools, and try to create a framework. So that's also why we have like the link to the GitHub here in the bottom, so actually where we share those tools that we have developed for others to investigate CT scans, and then investigate here, for instance, like the like materials which are consisting of several materials here, like rattan and the fungal mass in between, or analyzing like data, like those data sets, for instance, for networks and other things. Like, how do we, like my question here, how do we access the material level and integrate like the material level in the design and making of buildings? So I want to kind of end my presentation with this. Thank you very much, and I'm looking forward for questions and discussions.
Yeah.
Thanks very much, everyone. Thanks for all the speakers. And I'd like to invite everyone to submit any questions in the Q&A. And then we can go through there. Maybe someone has something to start off with.
Well, I can start with first saying thank you to everyone for really amazing presentations that look at very different aspects. And I could think of many questions to everyone, but perhaps I can just start, and then I let the floor to other people too. I would start by asking Mark. So Mark, how do we ensure, or how do we enable cascading more to happen?
A good question. I mean, I think the one thing that keeps coming around time and time again is about the costs. I mean, the virgin material is so inexpensive; it makes it very, very difficult to justify the expense of reprocessing the wood. And this comes through with the meetings I've had with, and discussions I've had with different stakeholders and so on. So I think unless we can somehow value the material in one sense, and maybe this is a kind of a, how do we get around this? That's, you know, people perceive wood to be, especially waste wood, to be a low quality material. Unless we can get over this somehow, then it'll always be a problem area, I think. I mean, of course, it's not always the case. I mean, we find that some kind of valuable species that maybe you can no longer get the virgin wood any longer, it acquires a lot of value because of its rarity. So I think somehow we need to kind of think again about how we perceive materials and how we value materials. I was just actually thinking to myself when Martin was presenting that all this information is gathered about a piece of material, and yet you go to the hardware store and it costs virtually nothing and it has no value, and especially when it's been used once, it has no value or very little. But all that information is going in there. It's kind of a little bit crazy. I don't have the answer to this, but I think that's maybe the economics is one of the key things, and how we value materials. Maybe we need policy or regulation now to support this second life use of materials.
Yeah, thank you. And maybe this ties in with Alison and how she talks about the commercial value. Alison, are you there? Yeah. Yeah. Anyway, I had a question. Perhaps if we looked at the building scale, then there's a different value to it. But yeah. And then to Martin, I thought that was really amazing, the complexity level that we can handle today. But how do we simplify it so that the industry will use it? I mean, I think like on one level, it's really, really fantastic that all this is possible. But then on another level, like, yeah, how do we come from that point, which is really having all the information available, to something that we can use tomorrow?
I think that it will take quite some time. But I mean, it's not that we are not used to architecture engineering, it's not used to complexity. And like, so when you see what's been happening in the last decade, from going to 2D CAD to 3D BIM, then that's like a huge step in complexity. And like now, like not everyday architect, but like any bigger architecture office, like in Copenhagen or elsewhere, is dealing with very, very complex tasks, like setting up like lifecycle analysis, where kind of clients, municipalities, at least on paper, they ask for it. So in order to kind of get some building permission, you have to kind of deliver all of this. And it's super, super hard for them. Also, there's a lot of research going on. You name it, the companies here in Copenhagen or elsewhere. And so there is like all this kind of knowledge and practice actually how to handle complexity going up. Plus you have to handle like hundreds of products at the same time. So I think there is some like a more like people or practice getting more data savvy, and we shouldn't underestimate it just because we don't teach it on bachelor level. So that what is actually happening there, and there are ways. How do you handle like that? You collect the right building material for your building your house. So there's something happening on the back end, and I'm very confident on a technical or like a user level. This is possible. I think what's really necessary is to show examples and like to kind of make those steps. I think that's what happened with digital fabrication or with 3D printing, and then at some point it clicked, and now you can see 3D printing concrete everywhere, and things like that. So that's why I think like work like Pasi, what you showed, like how do you actually use it, and how do you like make like gold from waste, so to say. So that's just like amazing.
Mm. There is a question here from Tom, but before I let the floor, I would like to ask Milan and Pasi. So also Martin touched on it. Well, how do we educate people for the future then? So Milan and Pasi, the same question, and then we take the question from Tom.
I can start. I think the discussion is really interesting because of this complexity. So we have to teach complexity, but also I think it ties a little bit to what Mark was saying. We actually have to get away from the point where we equal volume versus value. So if we can actually get to the point where we can create value from complexity, from being able to reuse materials, I think that's a good way. And the way to get there is actually a lot more holistic approaches to teaching. So we actually work together with students and include them in research, which I think is the biggest thing, because let's be honest, if we're going to face all these challenges by 2030 or 2050, we don't have the time to first do research, then write a nice book, and then maybe implement that on some course. So we really have to include students. And to be honest, the most interesting stuff in terms of what's happening in reuse of materials now is done by startups that are run by very, very young people. So we're seeing people going straight from studies and developing very new ways of thinking. So I think there's a lot of potential in just encouraging, first teaching the basics, and then encouraging students to find their way in early in their careers and actually try to make changes. And yes, some of them will run a startup to the out of the road, but some of them will make it. And this is how we get sort of new ideas. And I think that's probably the biggest important thing, is how do we get new ideas? Because it's not like we've explored everything yet. So that's my comment.
Yeah, and I think I would mostly agree with what Pasi had to say about it. I think that it's not necessarily a problem of how to kind of convey the information, because I think there are ways of kind of handling it, no matter the audience and no matter the complexity, if we kind of capitalize on using various kind of interfaces and modes that we have these days. But I think it has to start from the basics and from the kind of foundational principles of what it is you're trying to achieve with that. Are you trying to kind of get the students to, for example, become more aware about the sustainability potential of some of design materials, or are you getting them to kind of to a point where they themselves can work with that in their own projects in the future. I think what is very kind of a very good way to approach it is to kind of handle to have like very hands-on experience early on with either kind of in schools and kind of in workshops and kind of with projects on already on bachelor levels, and then later on also on the master levels, so that the students can kind of follow the maybe the kind of even the life process of a single piece of wood, or kind of an example of a material, so they can kind of get a better understanding of the genealogy of it all. And I think with that kind of knowledge, that will also kind of serve to motivate them for the future and to kind of get them to a point where they're like also more interested in exploring the complexity at a deeper level, which is, yeah, of course, again, something that might be a bit challenging if it kind of is tackled head on, but if you start from the simpler basics, it makes more sense to, and it's going to be more interesting to the students as well.
Thank you. And Zan, will you read out? We have a question.
Yeah, sure. There's a question from Tom, and here's a question for Mark. He comes from Canada, where construction demolition waste is landfill and therefore cannot even be incinerated, except for in the backyard. And as far as he can tell, there are no solutions in place for second use of wood products. Even something like biochar production is currently prevented by the presence of nails and varnishes, etc. Are there methods or practices in place that you know of to facilitate construction demolition waste reuse, I guess?
Yeah, I mean, it's a big issue, I have to say. I mean, of course, the obvious one is particle board production, but then that's pretty much prevented by when it comes to construction and demolition waste, or particularly demolition waste, because of the potential of presence of contaminants. But I mean, particle board production is a route to utilizing second life wood. But how it's implemented, I mean, of course, it depends on if there is a large industry present. I mean, there are kind of industry clusters in Central Europe and, for example, in Western Europe, big particle board mills, which do utilize quite significant quantities of waste wood. But mostly that is actually not construction or demolition wood. It's actually waste packaging, pallets and things like that. So the question of the demolition waste, that is problematic. We were in a project a little while ago, some years ago back now, where we were looking at how we could reuse demolition waste, and this was basically geared around cleaning, removing nails, rejoining, all sorts of a lot of processes there, which to be honest would be actually, I mean, when you think about the cost, it would be probably prohibitive to do it that way. So I mean, I don't know of any really good ways that it can be done now, which is why kind of I think this idea of particularly with demolition waste, which I think is why we need to think a little bit about how buildings are built and how they're demolished, and can we recover better quality material that could potentially be reused. I think that's maybe a better route, but the reprocessing route is problematic. And yeah, from kind of personal experience, working in the backyard with old beams, trying to remove nails and screws and other things, it's dreadful. It really is. So how you can actually do it in practice successfully, it's actually quite challenging, I have to say. So I don't have a ready answer.
Thanks, Mark.
Thank you. I just wanted to ask Alison, if I may. Yeah, Alison, you just, I just wanted to ask you, have you considered using your beautiful structures in a building scale? Because then the value is different. Yeah,
I just said it hasn't happened yet because that's not something I've attempted yet. I think it would be interesting. The things I've seen of bamboo where they are used as an interior, a kind of decorative element, seem quite unsatisfactory so far. They seem to be things that don't add anything structural. And so, as I say, that there is a lot of limitation with it. And then you have to find an application where it's likely to be a one-off, basically. Sometimes some public spaces will allow this sort of thing, but generally it's not happening. And I think other speakers have already said, if things haven't happened yet, there's often a good reason for it not to be happening. Certainly with architecture that would be external with bamboo in the sort of climate we have here in this part of Europe, it's not going to happen. That's not going to work either. So I've accepted that there are a lot of limitations, and you know, the list of things that I can do is quite a short one, but it's the more interesting list than the one of, you know, all the things that the unlimited number of things that I can't possibly do.
Okay, thank you. I think yeah, of course, limitations are there for everything, but I would push, and I don't believe that they can't be used outside, not in the same way as unprotected, but yeah, but that's a different debate. I just mentioned it because they're so beautiful, the things you do, and yet you talked about value. And often, like, the house we built is our largest investment in life. So if they could be part of our house, maybe somehow they gain a different value. But it was just a thought.
No, it's nice of you to, you know, to be enthusiastic. As I say, I try everything, but some things work better than others, and that's where I have to focus.
Yeah, of course. I haven't got anything more to say. I would just like to say thank you to all of you. We've exceeded the time a little bit, and I'm really grateful for your input, your amazing lectures, and also it was really lovely to see you all. I hope to see you all for real soon. Some I will see very soon, and others I hope in not so long. But Zan, if there was something I interrupted you, sorry.
I just have a quick question for Pasi. I want to say thanks for outlining some of those parameters that we can get around with the law. And it made me think about how much tax has been an influence in design and people avoiding certain tax or capitalizing on certain tax legislation to get bigger houses or use different materials. And I wonder if before legislation catches up and as people get more savvy like yourself, we'll end up with a kind of a new architectural style that's that's been influenced by both the parameters of required by reusing materials, but then also the kind of legislation restrictions that we have currently.
That's an interesting thought, because what we see is we see always that there's avenues of trying stuff out, and we see Olga showed a picture of a facade in Christiania. We also have places where people just do it, and this is sort of this approach to like not accepting the laws as they are, and then that actually does affect a lot of at least young students in terms of what we see in projects. So we see the projects develop during the studies, and we also see sort of let's just say we see different values popping up. Quite interestingly, this year approximately approximately 44 we had 44 theses on wood engineering. So wood is now larger than steel and concrete combined in terms of topics for master's thesis on engineering at NTNU, which is quite interesting. This is a complete flip last 3 years. We also see that oil studies or oil industry studies almost don't have enough students anymore to actually run the studies, but biotechnology is jumping up to 10 times what they can actually accept in terms of students. So I think that a lot of these, this is part of sort of the two-way game of legislation as well. We see young people making a stand, especially after Greta Thunberg, and we see that that is actually affecting a lot of the policy. So I think that not just in terms of style, but actually I hope that people are encouraged to actually go into the politics and actually change the premises of how we make architecture. And then obviously over time we will adapt both professional practice and other things. But there's no way of starting that without having places of experimentation and places of trying stuff out in the very early phases. If we don't have that, we don't inspire people, and we slow these processes down, I think. So I think it's very important stuff that Martin was showing, and also Alison, and this drive for experimentation, to explore. I think that's sort of the key issue every time we're working on something that's coming and not already established. Yeah, so I think that's probably best I can do as in terms of answer.
Thanks, Pasi.
Yeah, yeah. Thank you very much for being part of this webinar. I think, well, I certainly enjoyed it. I know that many others enjoyed it too. There was a point where we were 40, and that was really nice. And I really look forward to seeing you for real in not too long. Thank you.